Welcome back to Solving Problems Together, and today we're going to dive straight into a problem based around proof. We've been asked to prove that the sum of 3 consecutive integers is divisible by 3, the sum of 5 consecutive integers is divisible by 5, but the sum of 4 consecutive integers is not divisible by 4. So, that's what we've been told. What are some initial thoughts? I'm thinking I need to use algebra for a proof question. If we just choose one set of numbers, we're only proving for those values. If we use algebra, we're proving it for all integers or all consecutive integers. And whenever we use algebra, we're going to be using algebraic manipulation. So simplifying, rearranging, and solving. Let's represent the 3 consecutive integers. Whichever number I choose to be the smallest, I'm going to refer to that as n. So the number above that, so the number that follows that will be n plus 1, and the one that follows that would be n plus 2. So these 3 terms represent 3 consecutive integers. We get the sum by adding them together. Now, is this divisible by 3? Well, I can factorize out 3, which means yes, it was a multiple of 3. It's 3 multiplied by n plus 1, which means it is divisible by 3. If I can factorize out a term, then the expression is divisible by that term. So, we have the first statement. The sum of 3 consecutive integers is divisible by 3. Let's see what happens when we have 5 consecutive integers. Here's my 5 terms, starting with n and ending with n plus 4. When we add these together, we get 5n plus 10. Is this divisible by 5? I'm going to factorize out the highest common factor, which is 5. This expression is divisible by 5. So this fulfills the second statement. The sum of 5 consecutive integers is divisible by 5. What happens when we have 4 consecutive integers? Here are the terms to represent 4 consecutive integers. When we add these together, when we find the sum of them, we get 4n plus 6. Looking for the highest common factor, the highest common factor here is 2. We can factorize out 2. This expression is divisible by 2, but not divisible by 4. Interesting. 3 consecutive integers were divisible by 3, 5 consecutive integers were divisible by 5, 4 consecutive integers were not divisible by 4. So, we have proved the original situation, but hopefully, and this will be a good thing, it raises more questions. So far, the odd number of consecutive integers seem to be divisible by the amount of consecutive integers. The one even set of consecutive integers is not divisible by the amount of values. Is this a pattern that holds true? That sounds like a whole nother proof question. Can we generalize this further? Can we take this problem further? What if we just use consecutive odd integers or consecutive even integers or any other restrictions to make this problem more challenging or interesting? And if you can think of any, just join us in the comments where you can share your initial thoughts on solving the problems, any alternate techniques, and suggestions for enhancing this problem. Do come back again so we can solve another problem together.